Hello, I'm Jessica Banks, and I'm part of the Mathematics Centre for Enhancement in Education in the Maths Department at the University of Liverpool. I want to tell you about an auto-graded assessment I designed for an Intro to Pure Maths type module using the Mastery Assignment functionality in Möbius. My only connection to Möbius is as a user, and whilst some of what I'm going to say is about assessment options available in Möbius, most of the ideas can be applied more generally. The assessment is part of a module taken by the straight mathematics students when they first arrive at the university. Although it incorporates a range of different material, the module seeks to introduce the students to what university mathematics is like, particularly the sort of abstract, pure mathematics they haven't really seen at school. It's intended to help students develop core knowledge and skills they need to succeed on a mathematics degree, some of which we tend to assume don't need explicit teaching. Traditionally, we set out the syllabus for a module, and a student can achieve a pass by learning 40% of that. Some content is more central than other content, and the idea is that weak students learn the most important 40%, while stronger students also learn the more peripheral material. In practice, it often doesn't work like that, as students choose for themselves which sections to focus on. This can be particularly problematic with foundational first-year material, leaving students to continue with their studies without having mastered some of the key concepts that underpin their studies. I wanted to design an assessment that ensured students couldn't avoid learning the most important ideas. Accordingly, students are required to get all the answers right, eventually. Those who are already comfortable with the material simply complete the assessment and move on. Those who find it harder have the chance to improve their understanding and then try again. In terms of deciding the specific content of the assessment questions, I asked myself the question, what things are so important that I would be prepared to fail a student who was not able to do them by the end of the module? Now let's have a look at some of the individual questions that I created for the assignment. First, here's a basic multiple choice question. This is using the Maple functionality to draw the graph. One aspect of this question, which doesn't play into the assessment itself, was that I wanted to remind students that not all functions look like polynomials, trig functions, or exponentials. Here's another multiple choice question, this time with multiple selection rather than single selection. In this case, I've used a static picture file for the Venn diagram, while the set names and the combination of sets requested varies. This question uses the most mathematical question type, which is graded using Maple code. It's about making sure students understand that the variable in the function definition is just a placeholder. It was inspired by a tutorial I taught once, where I spoke to a number of maths students who, given f of x, were unsure what f of y was. The function here varies, as does the notation. There are a variety of different mathematical objects you can ask the students to input for this question type, one of which is Greek letters. Sticking with the theme of mathematical language and writing, here's a question to help students with learning definitions. Again, the notation varies. This is a free text box with a fixed list of one or more phrases for the students to match. It's also possible to include partial marks here, which in this example can be of use to students who are not yet completely fluent in mathematical English, i.e., all of them. However, since you have to specify every word you are happy to accept as an answer, I decided this question was only really suitable for formative assessment. Instead, for summative assessment of the same content, I settled on the matching question type. Here the students have two lists that they have to pair up. This is another question focusing on reading and speaking mathematics, specifically the symbols for all and there exists. As you can see, this uses a drop-down box to offer students possible phrases. One thing to note here, though, is that you cannot fix the order of items in the list without giving away information about which answer is correct. If you need to keep the options in order, multiple choice questions work better. Here is another question designed along the same lines, this time looking at negation. As you can include LaTeX in the drop-down list, these meant I could ask the students to input symbols that are not included on a keyboard or in the palette for the Maple graded questions. I consciously chose the layout of the boxes to emphasize to the students the block construction of these sentences. Another question type, which I like partly just because it seems slightly more fun, is the sorting question. It can work wherever you have objects with a unique ordering. By default, they are arranged horizontally, but by adding some custom CSS, I was able to create a vertical version too, which is better for longer text. I did create some questions sorting the steps of a proof into order, but they proved to be harder than expected. Finally, this last question uses the Math App question type. This is really an educational bit of Maple embedded into Möbius. This is the only one of these questions I've managed to construct, and that was by modifying some existing code. I think it would be interesting to explore what more could be achieved here for someone who knew enough about these Maple tools. So how does the mastery assignment type in Möbius work? You organize your questions into groups and specify how many questions the student needs to correctly answer from each group. Each question is graded as the student completes it before they move on to the next question. The questions are just the same as in other Möbius assignments, so have as much variation as you've chosen to code. If a student gets a question wrong, they're given another question to do from the same group, which will often mean the same question with new numbers. As students have an unlimited number of tries at a question group, there's the obvious problem that they might get the correct answer simply by guessing, especially, for example, with true-false questions. Möbius allows you to set penalties for wrong answers, in the sense that wrong answers cause the number of correct answers required to increase. This is great in that you can reduce the likelihood of students correctly guessing the answer, for example by requiring 2 correct answers in a row. The format for these penalty rules is overly restrictive though. Allowing more flexibility would make this assessment type much more powerful. In terms of practicalities, I made the assessment available to the students throughout semester weeks 6 and 7, after we had covered the relevant material in class, and those who had not passed had another opportunity to complete it in week 11. They had access to anonymous formative assignments beforehand with similar questions. I also split the assessment into 4 sections that they could tackle independently. I deliberately set a deadline partway through the semester so that the students had a specific date to work to rather than just forgetting about it until the last week of the semester. I was also keen to have a specific date at which I could identify students who did not seem to be engaging and might need additional support. But that's a different story. Thank you for listening to this talk. I hope it gives you some ideas you can use in your teaching.